Okay, I want to take a look at an example that is a little bit more complex than just looking at a single half reaction in both an acidic or a basic solution. So this solution here, or this reaction here, is actually in an acidic solution. That would have been information provided to you in the question. Now, it's a little bit more complex than simply pulling out the reactants and the products. In fact, because there's two half reactions, we'll have to do that twice. So in our first half reaction, I like to pull out all entities that are similar to each other in terms of the atoms present. So my first will be my iron, so my Fe2 positive, that goes to Fe3 positive. So this is my first half reaction, and essentially I still follow the same 5 steps, but I can stop once I'm balanced and everything's balanced in both mass and charge. So my first step is to balance all ions or all entities other than oxygen and hydrogen. Well, in this case, I don't have oxygen or hydrogen. So then it says balance your oxygens. Well, I don't have oxygens. Then it says balance your hydrogens. Well, I don't have hydrogen, so the following step is to balance my electrons. I have a 2 positive charge on my left-hand side and a 3 positive charge on my right-hand side. And in order to balance my charge, I simply need to add 1 single electron. Now, because this is an acidic solution, I don't need to consider any further steps, and this is simply my first half reaction. Now, if I'm to label this, since I'm losing electrons, what happens here is an oxidation. Half reaction. Now, for my other entities present, let's go with this one, I have, titanium oxide, and it forms solid. So this is the step where I might need to add some more things in, and I may have a different way of balancing this. So I'm actually just going to give myself a little bit more room, and I'm going to move this guy over here. So again, my first step is to balance my oxygen, or balance my other atoms other than oxygen and hydrogen. Well, I have one of each on either side, so I now can move on to balancing my oxygens. So I do that again by adding, how do I want to do this? I can add my water molecules. So I have H2O that I can add to this side. Now I need 2 of them because I have 2 extra oxygens on my reactant side, meaning I need 2 oxygens on my product side. Now that I've added my water molecules, I need to add my 4 hydrogen ions onto this side here. Now again, because I'm only dealing with an acidic solution and not a basic solution, all that's left here to do is to balance my charge. So once I balance my charge, it looks like I have a 0 net charge on my right-hand side, and I have a 4 positive, meaning I need 4 electrons. Once I do that, I've balanced my mass and charge for both my reactants and products side. Now, the trick is that this, when I go to label it, is also going to be the opposite of my oxidation, which means it will be a reduction. Now, the most important thing we have to remember in redox equations and redox reactions is that I always have to have the same number of electrons that are oxidized and reduced. So I have to have the same number of electrons transferred. Well, what I see that I have 4 electrons transferred in my reduction equation and only 1 in my oxidation. So what that means is I'm going to need to multiply my top half reaction by 4 in order to balance all of my entities. So when I come up with my final reaction here, or my net reaction, I have 4 Fe2 positive plus 4 H positive plus 1 titanium oxide. Now, I'm not going to write down my 4 electrons because once I do this, I should be able to cancel out my 4 electrons on both sides. So what's left behind is my 4 iron 3 positives, my titanium, and my 2 water molecules. Okay, this is a way to balance a chemical equation, sort of using our half reactions and using what we know about our half reactions in order to get a proper answer. Now, the assignment that you have is very similar to what I have shown you here, where you have to pull out 2 half reactions. Now, the key is to look at the type of solution that you are going to be creating that your half reactions or balancing your half reactions in. Now, the one thing I don't want you to forget is do not forget to write out a net reaction or equation for that both half reactions, for that redox reaction, because without that it really doesn't make a lot of sense to just look at each half reaction, but to look at them together it does make sense. This is the best way to write it, to write out your first half reaction, your second half reaction, and then show the balancing or the net reaction overall. Again, you can practice some more simple half reactions in the textbook, and once you feel confident with this example that I've gone over and you're understanding both steps that I've gone through, then you may move on to the assignment, which is called Balancing Redox Equations with your half reactions. Okay, good luck!